Super Mario Brothers. Here we go. That'll work. Can you ever really have too many pipe stands? I don't think so. All right, so this section of piping is actually from Salt Lake Airport. A friend of mine works in there. I believe this is an expansion joint for their chiller. I could be wrong on that, but he called me up, said this section of pipe is leaking. If you've been to the Salt Lake Airport, the ceilings are really high, so they had to do it from a MAM lift and get it out of there and obviously drain the line. So there's a few spots on here that are pretty suspect. So let's go through and we'll take a look at it. I'll show you guys what I'm thinking on how to repair it. You can see they've marked direction on all of these, every one of them. You can see they've hit it with a wire wheel, but there is some wicked undercut. I mean, you can stick your fingernail in this. And I'm not sure if that's where it's leaking. He sent me a picture. Okay, so this one actually looks pretty good here. I'm still gonna hit all four of them just to make sure, and I'm gonna hit them all the way around. I believe this part right here, you can see, goodness, that undercut is terrible. It's like where it's pitted right here, it almost looks like the pipe has started to corrode. And that's why it's leaking. That's what it looks like to me. The other complication is we got dissimilar metals here. So this is stainless steel, this is mild steel, and I'm assuming that the weld is 309. So I'm gonna re-weld this with 309, and I'm gonna weld it over here. I'm gonna put another pass right here up the center, and I'm actually gonna gouge this out a little bit. Here's another one, and you can see it's the same. You can stick your finger under there. I'm pretty sure that's what's going on. Oh yeah, this is probably the worst one right here. It's actually kind of eating away underneath there. I think they tried to save money, so instead of using a stainless pipe fitting, a stainless 90, they went with carbon. And because they've welded the expansion, the stainless expansion piece to the carbon, for some reason the carbon has started to corrode there. If this is the line for the chiller, I know the chemical that they run through this stuff is a little bit corrosive, so that could be why this is going on, but you can see right there, same case. So I'm actually going to give him a call and talk to him about this real quick and just let him know that that's what I think's going on and see what he wants to do, just to make sure he doesn't want to, I don't know, have a new one fabricated out of completely stainless. This one here is not, it doesn't look like it's started eating through yet. So that's kind of the plan. So I'm going to give him a call real quick. Once I get an answer on what he wants to do, then we'll push forward. So I'll get back to you guys. All right, guys, so I just got off the phone with the customer. It sounds like that's what's going on. It sounds like the chemical that treats the water inside this loop is corrosive, and it's eating underneath the stainless through the carbon. That's what we think's going on. So you can see that there's some pitting going on there. I don't know why the crap they didn't use a stainless fitting right here. This is a really delicate joint where you're going from this, you know, Schedule 40 elbow to a stainless steel expansion joint. I don't know why you wouldn't put that there. And after talking to him, it turns out that there's another one that's leaking. So they may have me weld that one up. They may not, because if we weld it up and it just keeps digging its way underneath the stainless and leaking, there's no point. They're just going to have some new stainless ones fabricated. So that's kind of the plan. I'm going to start by hitting this with a wire wheel, getting it all prepped up. And then I'm going to take a pipe liner, grinding disc that's like 3/16, and I'm going to gouge this out and give myself nice clean material to work on. I'll go ahead and get this cleaned up and prepped up. I'm going to start just on this one, and then I'm going to run one and see how it runs. If it runs okay, he said just go ahead and weld it up, and they're going to use it for a spare. So we'll go ahead and get our safety gear on, get this prepped up, and see if we can't run a weld on this and see how it's going to go. Let's do it. All right, guys, so here's what we got. We got it all ground out. I have figured out that, yes, that's what's going on. It's eating through the carbon underneath the stainless. I'll give you guys a close-up here. I've taken my grinder wheel and kind of dug down into the crack, and it's rusty down in there. So the root on this is not going to be fun, but I talked to the customer, sent him pictures, and he asked me what I thought. And so I told him, well, ultimately it's up to you. If the purpose of welding this up is to give you a spare so that it'll buy you some time to get it replaced, I can't guarantee that it'll last any more than it already has, which is 4 to 5 years. So that's probably good. So if he needs a spare, he would have it. But it will eventually rot out again, just because of the way it's fabricated. So he decided, let's weld it up so I have a spare. So that's what we're going to do. So I'll show you guys a close-up now. Okay, so you can see that crack there. That's where it's been eating under the stainless through the carbon. And that's why this surface right here, you can see a little bit of it right there. That's why that was all pitted, is it was leaking through there and just eating this surface metal away as well. So let's go ahead and get all set up and we'll see how it goes. All right, guys, we're running 309, 332 TIG rod here for our root. We got our machine set at 125 amps. I am running the foot pedal, and we're running 100% argon. I've got a number 10 cup on here with a gas lens. Let's see how this goes. This could be interesting. Just going to throw my rod on the ground real quick. It's always good luck. It's always good luck to do that first. Oh yeah, she's popping. Okay, so I got my pedal to the floor, and I think it can still be hotter. So I'm going to go ahead, turn this up to 150. The camera died in the middle of running that root, but I got the root in. It's decent. It's about what you would expect, as dirty as it was. But the good thing is I really didn't get any pinholes. So I did clean that up just a little bit with the grinder, and now I'm running a cap pass over that. We'll just continue to run this. When I get done running this, we'll come back and give you guys a look. So one thing I'm making sure that I do here is I'm making sure that I tie in with the carbon as good as I can. So I'm actually pausing on the carbon side just to make sure that I give it some time to fuse, and then I make sure that I'm feeding plenty of rod as well. Man, that is weird stuff. It's weird welding that. It's crazy how when you get to that carbon it just kind of acts different. Okay, I had to go a little bit wider on my stitch up here. Still looks good, but did have to go a little bit wider. So now I'm going to go on the inside here and weld up this other way. Okay, I think I'm going to jump up to 1/8 inch rod. I'm just having to feed that 332 really fast. So I'm going to jump up to 1/8 inch. Alright, so I'm using my mild steel brush here. You don't want to use your good stainless brush on this because you're going to get it all contaminated if you do, where you're touching the carbon steel. But where you got stainless touching carbon steel, you definitely just want to make sure that you use your mild steel brush. Nobody judge. I don't claim to be the best TIG welder around, but I do think it's going to work. You can see I don't have any undercut. It looks good there. I like the way it's fused into the carbon. Okay, so there's one down, and when I say that, what I'm going to do is I'm going to go through and weld the tops of all these joints, and then I'll flip it over and weld the other side, and then I'll be done. But I don't want to flip it back and forth because that'll take forever, and it's kind of a rather large section of pipe to flip. It's not going to hurt anything to do it this way, so that's what I'm going to do. The toe of the weld, when I say the toe of the weld, it's that corner right there. So I'll run my pipe liner right in that corner, give myself a nice groove, a nice deep groove that I can fill back in with weld. So we'll just keep on keeping on. So we'll go ahead and keep working at this, and we'll give you an update once we make some headway. Alright guys, we got the one side of this completely welded out. All that's left to do now is we'll flip it over and do the same thing we just did on the other side, but it's 9 o'clock. Done just in time for dinner. Ha! I'll go ahead and give you guys a look at how this turned out. I've already seen the first one. You can see there's no undercut. So I think this is going to work out. I think it's going to buy him some time. I'm happy with the way it's going together. It was a little bit tricky figuring out how to weld with this rod. Like I said before, I found that if I pause on the carbon side and give it a chance to kind of wash in, it flows together a lot better. And that is also one of the things that I think's helped me avoid getting undercut. So it's turning out. Pretty happy with it. All right, well, I'm gonna go in, eat some dinner, shower. We'll be back in the morning to finish this one up. All right, guys, so we've got the top half of this all welded out. So all that's left to do is to rig it up, flip it over, and weld the other side out. So let's do that now. This is where having the right equipment, having the right rigging, those are the things that make the difference in being able to do stuff like this. And a little update for you guys that are interested. The new hoist from Pro Winch has been awesome. I'm loving it. As a matter of fact, I'm loving it so much that eventually I may end up getting another one for this other side. So I'm just going to bring this back over here. I love the variable speed. So I'm just going to disconnect these to just roll it over. And then gently just let her go. It's nice and easy. There she goes. All right, guys, so we got this all prepped up. I want to show you guys what it looks like when it's all prepped up. So you can see I've put a little bit of a gouge in there. This side on all four fittings is not near as bad. I'm wondering if this is the bottom side, because every one of those had a little bit of that undercut. I shouldn't say undercut. Every one of those had spots where it was eating underneath through the carbon. So this side I haven't had one spot where it was that way. So I'm wondering if this isn't the top. But that's what my prep looks like. Now, when you find stuff like this, it's a little concerning, because you can see they were running this way and they were running this way. And their tie-in must have not been very good. And so instead of grinding that out and making it look nice, they just put a little right there. And then they just left it. So that kind of stuff concerns me a little bit. The other thing I want to go over is I just want to give you guys a little bit of information on how to walk the cup. Now, I'm not the best at walking the cup. I can do okay, but I'll just show you guys how I do it. All right, so the best description I've ever heard of how to do this is it's a lot like if you were to take a 50-gallon drum, tip it back, and then walk it across the floor. That's kind of what you want to envision when you're doing this. So you'll take your cup, I'll give you guys an up close on this. So you take your cup, you set it on the material, okay, and then you feed rod like this. Now, I'm right-handed, so I put the torch in my right hand, and then as you go, you walk the cup like this. So you're walking it back and forth. So you would twist and roll, and twist and roll, twist and roll, twist and roll, and then you just, the more you do it, the faster you'll get at it. And like if I'm running small bore pipe, I can actually walk it pretty quick like this. And you'll kind of hear my cup slipping a little bit right there. It's interesting. Once the metal heats up, this ceramic kind of grips to the steel a lot better. That's kind of how I do it. There's a lot of different torch setups you can use. I'm using this number 10 with the gas lens. It is a Jazzy 10 Furic cup, and it does have the gas lens on it. I just feel like I get better coverage, which when you're welding with stainless is important. So I just wanted to give you guys a little bit of info on that. All right, I'm gonna go ahead, put some music on, get going with the beat, walk the cup with the beat, and we'll see if we can't knock this out. All right, guys, so the welding is done. So the next thing to do is they did bring me 2 flanges and some bolt packs so that we could bolt some blind flanges on this and be able to pressure test it. So I'll just go ahead and show you guys kind of the quick process for that. You have to get these flanges clean. If you don't get the flanges cleaned, you're just asking for it to leak. So there's some old gasket here. So I'm just taking a putty knife and I'll go ahead and clean what I can off that. So anything that's protruding past the grooved surface there, I'll go ahead and scrape that with this putty knife. And then once I get all that scraped off, I'm actually going to hit it gently with a wire wheel just to try to clean this crud off that's down below the grooves. The grooves are kind of what helps it seal. So you want to try to get those grooves as clean as possible. What a mess. So just do your best to get what you can. When you tighten this down, the gasket will squish down in those grooves and it will help seal, but you need to try to get it as clean as possible. So now I'll hit that with a wire wheel, kind of knock all that crud out of those grooves, and this one will be ready to bolt our flange and our gasket up. So we'll go ahead and do that now. Okay, so hopefully you can see the grooves are still intact. I haven't hurt the grooves, but they are clean. I've been able to knock probably 95% of the crud out of those grooves. So that surface is nice and clean now and ready to bolt up our blind flange. The maintenance mechanics that have to bolt this back up are going to appreciate that it's clean already as well, because now they don't have to do it to get it prepped up and ready to go. So you can see this one still has the gasket on it. So we'll just pull that gasket off And then we'll have to clean all the crud off of this one too. We'll go ahead and do that off camera and get that one cleaned up. When we're ready to bolt these flanges up, we'll come back to you. All right, guys, so we're actually going to be using studs. That's what they brought us. And they did bring us some nuts as well. Okay, so I've got 3 studs in this. I'm going to go ahead and grab my blind flange. I'm going to slide it on here, and I'm going to get some nuts on there. It's going to be a little bit tricky when you're doing it by yourself. You definitely don't want to drop it on your toe. So now that I've got a couple nuts on there, I know that I'm not going to drop it on my toe. And I want to leave those loose because I'm going to drop my gasket down in there and get it all centered up. The bolts will actually help center up where the gasket needs to go. So we'll put some more studs in this. We can put the rest down here, and then we'll drop our gasket in, and then we'll be able to put the rest in. So we'll get these all in. And once I get these blind flanges all bolted up, I'll show you guys what my plan is for pumping it up and checking the pressure. All right, guys, quick update. I pulled the plug out of here. I did run a tap through there because it was all packed full of rust. I had to run to the hardware store to build this little apparatus. And this is one thing you want to make sure that you include in your bid. If you decide to do a job like this, you need to include this kind of stuff into it, because this cost me 60 bucks to build, and I really didn't account for that. I thought I had the parts to do it, but I didn't. So just another one of those things you guys can learn from my mistakes. Okay, so the gauge on here goes up to 200 psi. We're not going to pump it up to 200 psi because it's not necessary. Customer told me the most that this pipe will ever see is 80 psi max. So I am going to pump this up to about 120. That's what I got my regulator set at, because I want to go a little bit overkill. The other thing you guys need to know is when you pressure test a pipeline, if you pressure test it with air, it's different than if you hydro test it or test it with water. The pressure is different, the amount of force there. So just be aware of that. For us to test this with air, it's going to be just fine for what it is. It's not a high pressure line. So I'm going to go ahead and hook up my air hose to this. I'm going to open the valve. That's going to release the air into this chamber. We've got it isolated with our blind flanges. We'll go ahead and pump this up. My pressure gauge is on the opposite side of the valve, so we'll be able to pump this up, see what the pressure's at, and once we hit close to 120, 110, we'll go ahead and shut it, and then we'll see if it will hold pressure. And then I'll actually walk around with some soapy water and I'll spray the flanges and spray the welds and make sure that nothing's leaking from anything that we touched. Here we go. See the pressure's going up. Probably going to take a minute. We'll just go ahead and let it do its thing. When we get, oh, there goes the compressor. So we'll go ahead and let this run, fill up to where it needs to. We'll shut the valve, and then once we get up to pressure, we'll come back and give you guys a look. All right, guys, so we're just about there. It's a little over 110, and I think it's kind of stalling out there. So I'll probably close the valve now, and we'll see if that holds. So far it looks like it's holding. So usually when you do a hydro test, you'll pump it up to pressure. Once you get it to pressure, close the valve, and then it usually has to sit for a certain amount of time, depending on the pipeline, and there's a lot of variables there, but that's how the inspector determines how long it needs to sit with pressure under it. Where I'm the inspector, I'm just going to shut the valve and let it sit, and we'll see if it holds. If it holds, I'm still going to go through and check all my welds with soapy water, just make sure there's no hairline cracks or pinholes or anything like that that are leaking. I don't expect we're going to find any, but things are looking good so far. So we'll go ahead and go to that point now. Okay, so she's holding right there. This is something that I just keep in the shop. It's like 50% dish soap, 50% water. And then if you end up getting any leaks, you will definitely see it because it'll blow big bubbles. Everything looks pretty good on that one. Like even when I spray it on here, it's pretty foamy. If you think, oh shoot, there's a bubble, you pop the bubble. And usually if there's a leak, another bubble will appear, but everything looks good so far. The other good thing about doing this, I like to take pictures, so I'll take pictures of the gauge and I'll send it to the customer so that they know that I did pressure test it. It's kind of creepy. You can hear this expansion joint moving. Kind of makes you not want to stand here. Okay, I think everything passed. All the welds anyway. It's still sitting exactly where I left it. So, I mean, if it's sitting there I'll probably leave it. I got to go somewhere in about an hour. I'm just going to leave it, let it sit. And if I come back and it's sitting exactly where it was, then we know it's good. But I've tested enough stuff like this, fuel tanks and stuff like that. Fuel tanks, obviously, you don't want to go near this pressure. But I've tested enough fuel tanks that usually you know right off the bat if you have a leak. And I'm feeling pretty good about this. So you can even check your pipe fittings there. So everything looks good. Well, I think we won that battle. So once again, I appreciate you guys watching. Hope you guys learned something. Thanks as always. See you on the next one. This is something that I just keep in the shop. It's like 50% dish soap.